Now, let's look at another example. Consider the case of a spring that is attached to a box. Tapos initially, our box is compressed. So after a while, as you allow the spring to expand, turn to its original uncompressed length, so it is now moving yung ating box. Until such time na it reaches yung kanyang original uncompressed length. So just to label it, the original uncompressed length ng ating spring would be at this point here. So yung value ng ating x mamaya sa equation ng elastic force, at this point it should be 0. Okay? And then it started, ito yung initial niya na position. Ang displacement niya, final displacement, will be a straight path. Another given information, yung ating spring constant for this spring, that is 250 Newton per meter. Another given information, yung kanyang total displacement, that is 0.021 meters. Yun yung length ng total displacement ng ating box as it is pushed by the spring. Now, what we are asked to find here, we are asked to solve for the work done by the spring. Okay? So, to solve this, we will use yung integral natin na notation for the work done. So, you want to solve for the work done by the elastic force. So, that is simply the integral from point A to point B of the elastic force. It is changing, so it is dependent dun sa ating displacement S. And we will dot that to ds. Or this is equal to the integral from A to B of the magnitude ng ating elastic force, ds cosine phi, where phi is the angle between your force and your ds. Pero kung tingnan yung figure natin, ang ating force is to the right. Tapos, yung change in the displacement is to the right then. So, pareho siya ng direction. So, this will take a value of 0. Cosine 0, that is equal to 1. So, we are left with the elastic force, integral from A to B, F elastic times S ds. So, ito yung gagamitin natin na equation to solve for the elastic force. Now, yung magnitude ng ating elastic force is given by this equation. That is negative kx. By the way, yung negative na ito doesn't mean that our magnitude is negative, pero it only means that the direction is opposite dun sa direction nung compression niya or stretching nung ating spring. So if this is the value of the elastic force by the spring, then the magnitude nung elastic force is k times x. So again, hindi natin tinake yung negative kasi this negative will only affect the direction. Tapos for this case, we are only interested doon sa magnitude nung elastic force. So we will plug this magnitude doon sa ating equation mamaya. Pero notice na instead of being dependent sa ating displacement S, dependent yung ating magnitude doon sa value ng x. Which is, if we go back to our figure, dito sa starting point ng ating object, ang value ng S mo is 0 pa kasi wala pa siyang displacement. Pero the value of our x is this length here, this vector here. Yan yung ating x. By the way, x is the amount of compression or stretching ng ating spring from its original length. Okay? So, ito yung original length natin. Now, as it moves, nag-increase yung ating displacement S. Okay, so parang ganyan na yung ating displacement S. Tapos lumiit naman yung ating displacement X. So lumiit yung X. Until such time, dun sa final motion natin, dito na side, buo na yung ating S dito. Tapos ang ating X, since bumalik na siya sa kanyang original unstretched length, yung ating spring, then 0 na siya dito. So we can see from this idea pa lang, we can actually express yung ating displacement S in terms of the compression X. So, S plus X is equal to 0.021 meters. So, we can see this to be true for any point doon sa motion ng ating box. So, sabi nga kanina, sa starting position, if you add yung value ng X, which is 0.021, di ba? Ang length nito. Tapos i-add natin sa 0, we get 0.021. Dito naman, if you add yung length ng S sa length ng X, so you still get 0.021. And then sa final na position, this is 0.021. You add 0 to that, you get 0.021. So we've seen yung relationship ng value ng displacement and the compression X. And we can express that in terms of this equation. So again, gusto natin palitan yung S ng X para isa lang yung variable natin sa integral. So we can write this as 0.021 meters minus X. Now we can get the derivative ng S. So you'll have ds. Ang derivative nitong constant natin na 0.021 meters is 0 kasi constant siya. Then we are left with the derivative of negative x, which is negative dx. So this time, using this equation here, we can replace yung ds natin by dx. So matira sa ating equations are all expressed in x. So let's plug in yung values natin. So elastic force is integral from a to b of F elastic as a function of x. Nakita natin kanina, it is a function of x. So this should be multiplied to ds, but we have shown that ds is equal to negative dx, as shown here. Tapos, let us substitute yung value for the magnitude ng ating elastic force, and that is kx. So we got this from this equation here. So you have negative dx. Now, since alam natin that we will be integrating in the variable x yung ating variable, we will solve the integral from the x at point A, which is yung starting point, anong value ng x nun. Tapos, we will solve the integral up to x at point B, which is yung value nung x at the final position. So, let's do that. So, the work done by the elastic force is from x sub A to x sub B is negative kx dx. Now, we can move yung ating constant outside of the integral. It doesn't change during integration. So, x sub A, x sub B, so you have x dx. So, ito yung integral na kailangan natin i-perform. So, the integral of x dx, that is simply, ito yung constant natin, the integral is equal to x squared over 2. So, we will evaluate this from the starting value ng x to the end value of x. So, evaluating doon sa start and end values, we should get negative k xb squared over 2 minus xa squared over 2. So, let us substitute yung given values natin. Our k is 250 Newton per meter. So, this is from our given information kanina. Okay, so we have here. Now, we need to ask ano yung final value nung x natin. So, if you go back to our figure, so ito yung final na position ng ating box. And the value of x at that final position is 0. So, xb will be 0. So, substitute natin. So, you have 0. You square that. Divide that by 2. Next, we need to ask what is the value of x sub a or the value of x at the starting position. Now, this is not a vector, so we are only interested with the magnitude. Gaano siya kahaba. So, from our figure, the magnitude of x at the starting point is actually equal to 0.021. So, yun yung ipa-plug in natin sa x sub a. So, let's put that. 0.021 meters. Tapos we will square that divided by 2. Okay? So, we will plug this in sa ating equation. Tapos, let us round off yung ating final answer into two significant figures. So, you should get 0.055 joules. So, ito yung work done by the spring, by the elastic force, doon sa ating box. So, that's how you use yung integral form ng work done in solving problems with non-constant force.